As the final activity in Unit 3, you're going to take a look at 3.9, Statistics and Quality. Under the assignment 3.9, check the Resources tab and click on the following link for a sample spreadsheet that looks like this. This will be a place where you can record the data for 27 3/4-inch wooden cubes. You're going to be measuring the end grain of these cubes, and if you need to see how to do that, check out the other demonstration video under the Resources tab. You're going to need to record the end grain length for 27 wooden cubes, and then you're going to use Google Sheets to calculate the following data, as well as create a histogram to interpret your data. What I've provided here is some sample data to demonstrate calculations. You'll need to record your own data, calculate mean, median, mode, range, and standard deviation, as well as create a histogram and justify whether or not the histogram shows a normal distribution or not. Conclusion questions should also be answered in the spreadsheet under the second tab in the following spaces provided. While you are encouraged to use one spreadsheet for data collection between you and your partner, it is suggested that you make a duplicate, complete the calculations individually, and see if you get the same numbers. There's a number of calculations going on here, and so there is an opportunity for mistakes to be made, which is why I would encourage both partners to record the data independently, although only one needs to be turned in on LMS. In order to make a copy, once you've accessed the spreadsheet, you need to go to File, Make a Copy, name it something appropriate, click OK, and then back under File, choose Move to Folder, and move it to your shared IED folder of your Google Drive. Once you and your partner have each collected and recorded your data, you're ready to begin calculations. It would be advisable to organize your data based on least to greatest length, from the smallest measurement to the largest measurement. I'll show you how to do that. I'm going to go into full screen by hitting F11. You're welcome to do the same if you'd like. In order to organize my data, I'm going to click on wooden cube number, and then I'm going to hold the Shift key while I navigate over and down until all of my data for length has been selected. I'm then going to right click on my data, choose Sort Range. My data does have a header row. One column said cube number, one column said end grain length, and I want to sort by end grain length from A to Z, or in this case from the smallest measurement to the largest measurement. You can see it's done that for me. 0.74, 741, 745, 75, all the way up to 0.766. At this point, you're ready to begin creating some of your calculations. I would encourage you to use Google Sheets as the tool it's intended to be. Don't do these measurements by hand. If you understand the formulas you can use, this can save a tremendous amount of time. So for example, I'm going to type an equals symbol, which indicates to Google Sheets that it should expect a formula to follow. And mean, otherwise known as the average, will be typed in, followed by an opening parenthesis. It's going to ask what data do I want to average. I want to average my first data point all the way down to my final data point. Enter. Notice it's calculated a mean for me. That mean can be updated if any of the data points turn out to be wrong, if I were miscopied in the first place, for example. Median is another standard code for Excel. And again, we would say find the median value of the following values. In this case, 0.753. Mode, so equals mode, and then again of the following values. Another way to enter these values is by hand. So my first value occurs in cell B2, so I can type in B2, then a colon. That indicates that it should be found between cells B2 and B28, which is the last one on my list here, so I'll type in B28, close parenthesis, and hit enter. So my middle number, or my most occurring number in this case is 0.748. Range is not a standard calculation in Google Sheets, so what we'll do in this case is type in a formula to calculate range. You should recall that range is the highest value subtracting the lowest value, so we'll go down to cell B28 again. We're going to subtract cell B number 2, which should have the lowest value. This is one of the advantages of having sorted my data least to greatest. It's going to automatically organize my largest data point at the bottom, my smallest data point at the top. And so here I have my range, 0.026. And lastly, I'm going to equals an STDEV for standard deviation. Select that formula there. And again, select my data set, B2 down to B28. Close parenthesis. My standard deviation. Just as a quick recap of what standard deviation represents. It represents an over and an under, within which I would expect that approximately 95% of all future data would fall. I could say my mean right here, 0.752, so that's cell E2, plus my standard deviation, which is in cell E6, E7, let's see here, how would I type that? E7, and then equals cell E2 again, minus cell E7. And those numbers came out the same, so it should have been E6, looks like. And so there's where I would expect 95% of all these cubes in my data set to fall, between 0.76 inches and 0.75 inches. I'm rounding there, 0.745 and 0.761. In order to create our histogram, I'm going to come down somewhere around here, and I'm going to hit Insert, Chart, and I'm going to select my data set here, B2 down to B28. I'm going to choose a histogram, which is going to sort all my data into class intervals and then graph them based on frequency. I'm going to customize my chart a little bit and call this a histogram of 3/4 inch wooden cubes by end grain length. And one thing I'm going to do is I'm going to come down, because I'm asked to sort this into 7 to 10 class intervals. I'll take a look at my range of values here. It goes from 0.74 to 0.766. So that's an increase of, we looked at our range a little bit ago, 0.026. So 10 class intervals would be that number divided by 10, so 0.0026. I can come down here, right click on my chart, advanced edit, and I would go down to bucket size, and I would say that I want my bucket size to be 0.0026. And so what it's done here is it sorted my class intervals into ranges that start out with 0.7384 up to 0.741, 0.741 up to 0.7436, and it's increasing by this amount each time. I can make that a little bit more standardized if I want to do 0.0025 or 0.03, because it does say 7 to 10 class intervals, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives me 10 right there. So I can even go larger than that. 0, 0, 4, 1, 2, 3, 4, 5, 6, 7. So, but 7 to 10 is what it's asking for. So I'm going to leave that 10 class intervals right there. Horizontal axis should be given a title. So those are my class intervals. It's going to appear right down here. I'm going to ask for a horizontal axis, left vertical axis. That's going to be the number of occurrences. So how many times we have a cube that falls in that particular bin range, or that particular class interval. And I'll hit update, and we can see my histogram appear right there. So you'll need to provide a little justification for whether or not this represents a normal distribution or not. There's a good chance yours will be a little bit closer to a normal distribution than mine is, because you'll have actual data that you're collecting, whereas these are numbers that I simply made up on the fly and won't necessarily represent a good sample selection for this particular activity. So a couple reminders as you work on this with a partner. You should each make a copy. All right. Reason being, there's a lot of room for errors in data entry here, so it would be best if you both put the data in. You should each complete calculations and then check with each other. If you get the same number, there's a good chance that you're doing things right. If your numbers are off by tenths or even hundredths, you're probably not doing the calculations right, and you need to figure out who's doing that right. But only one needs to be submitted. You've been put into groups on LMS, so as long as one of you submits an assignment, don't forget the conclusion questions, then it'll be checked off for the both of you. I'd encourage you to share this document with your partner. You can type in your partner's name here so that you could access it and work on it simultaneously. But I would still suggest that you take the time to check the data individually, make sure you guys are doing things correctly.